All right, here we go. We're going to just take a second and go through the review. Page 27, 13, 14, 22, 29. Page 68, 10, 11, 18, 20, 22, 30, 37, 41. And if you guys are following along, those problems, page 108, 22, 24, 28, 32, 34, 37, and 55. All of these have a chance to be on the test, and in some cases you'll make sense why they're on the test. So I'm just looking at chapter 1, page 27, 13, 14, 22, and 29. I'm not going to waste time on the video. If you have specific questions on how to make certain conversions work right, obviously one that we'll use over and over is miles an hour to meters per second. That one will be on there, or kilometers an hour to meters per second. I guarantee it, that one will be on there some fashion. You saw it on the last test. Make certain you understand how to do it. Again, kilometers an hour to meters per second. It's a common one that you'll use over and over again. So I'm going to skip over page 27. Page 68, looking through, once I ever get there. Page 68, first question we hit is number 10. Is Sally driving around in the car? The key here on this one, grab a marker. So page 69, number 10. So we've got 30 minutes at 80 kilometers an hour. We've got 12 minutes at 105 kilometers an hour. And then we've got 45 minutes at 40 kilometers per hour. And then 15 minutes eating lunch at 0. So, see if we can sharpen that up a little bit. Yes, no, maybe. There it goes. Cool. So I'm gonna switch inks. So 0.5 hours, 0.3, 0.75 hours, 0.25 hours, 12 minutes. What is 12 divided by 60? 0.2 hours. So 0.5 plus 0.2 plus 0.25 plus 0.75. My total time is 1.75 hours. Now the problem is I can't do this, like, what do you do, average? So in this case you take this 0.5 times 80, that's 40 kilometers. 0.2 times 105, give me 21 kilometers. 0.75 times 40 gives me 30 kilometers, and whatever times 0 is still 0. So 30 plus 40 plus 21. I'm not a math major. I'm not a math guy. So that's 70, 80, 91 kilometers. So, and for some reason it froze. Love it. Anyway, there, we're back up. So now we go back to the question. So we found out how far she went and how long it took her. Determine the average speed. Oh wait, 91. Why is this thing being painful? And my mouse is going. Cool. .91 kilometers divided by 1.75 hours. 91 divided by 1.75 gives me 52 kilometers per hour. That's answer 1. Determine the total distance traveled. Well, that's easy. That's 91. And hopefully I am right. 91 kilometers an hour. So point. Oh, I did a math mistake. Did you catch it? 25, that's an hour, 0.7. 91 divided by 1.7. See, you get going too fast. 53.5 kilometers an hour, just because that simple math mistake. All right, so next problem, those are your two answers. Next problem you guys want to look at is the flagpole one, number 11. You can take a look at 11. I'm going to do the previous video. I'm taking the cop out because we don't have time. If you want to, you can look at the flagpole problem I posted on the previous exam. It's still out there so you can view it. So let's move on. Number 18. 18, bus slows down uniformly from 75 kilometers an hour. So number 18. So bus VI was 75 kilometers per hour, or just 21 meters per second. Thankfully, it was given in the book. 2 a 0 VF, 0 kilometers per hour in a whopping 21 seconds. They want to know how far to go, delta x. Hopefully you have equation in your mind. So you should have delta x equals if I didn't catch that. So you can do this, you can do delta x equals. I'm going to look at some of your equations you were given. For me, honestly, there's a very simple one. So in this case, sort them out of zero. Delta x equals 1/2 VI plus VF delta t. Hopefully put it in, and you should get 220 meters. So delta x equals 1/2 21 plus 0. Delta t is 21 seconds. So 21 times 21 times a half. $220.5. 220.5 meters. Two significant digits, 220 meters. Final answer. All right. So that's 18, 20, and 22. 20, 22. 20 is the same. 22. 22 and 22 accelerates and then decelerates. So the deal with 22, it's exactly like this problem here, except for the fact you have to use 2, because you cannot put an acceleration and deceleration in the same. So 22 travels for 5 seconds. So T1, 5 seconds. And then with an acceleration 1 of 1.5 meters per second squared, brakes for acceleration 2 at negative 2.0 meters per second squared for 3 seconds. Time to 3 seconds. So in this case, what's it asking for? What's the final velocity and how far it's gone? So we're looking for VF and delta x. So here we go. So easiest equation you can use, my list. So since we don't have initial velocity, you can use VF, actually VI plus a delta t. Also, you're going to want the distance. So delta x equals VI delta t plus 1/2 a delta t squared. Now the good news about this equation is you can sit and do it, plug everything in. For the first interval, VI is 0, acceleration is 5 seconds. Or excuse me, 1.5, and time is 5 seconds. So you get 7.5. Now the key here, okay, I'll jump to this. So then VI again is 0 times 5 seconds plus 1/2 times A, which is 1.5 times 5 squared. Yes? So that's a first interval. If we've done our math right, 7.5 and 19. So that's the first interval. That's speeding up. Now, just like the rocket problem, just like anything else, if you have two velocities, two accelerations, you've got to do the problem twice. So in this case, you set this exact same thing up, but now the second one, VF equals VI, well, that's a 7.5. Plus your acceleration 2 is -2 times 3 seconds. Just like delta x equals your VI, in this case, is 7.5 plus, times time, delta t, which is 3 seconds, plus 1/2, our acceleration is -2.0 times 3 seconds squared. So 3 times 3, 9 times 2 is 18. Actually, 9 times 1, that's -9, right? -2. So 7.5 times 3, you got me on that one. 22.5 minus 9. This is 13.5 meters. Time 6. So my speed is 1.5 meters per second. But distance, is it really 13.5? Or do I have to add both of them together? And that's what a lot of people did on the test. You had to add those two distances together. And hopefully, you add them together, you should get about 32. 19 plus 13, 32. All right. I'm going to double check. 30 and 37. 37. The rocket problem you're going to need to do. I would say definitely work through it. If you need help, again, 37. Where do you find 37? Previous video. Okay. And then give me a second, we'll make another video for chapter 3.